Alrighty, it's time for a few quick updates on what's been on the kind of progress end of things. So what have I been doing? Well, a few of the jobs I've done here in the main engine bay is that I've fitted a contactor here to control the shunt field supply, and that seems to be doing the job adequately. It's just a normal Albright style DC contactor, and it is set up currently so that it engages upon the application of throttle and is disengaged 5 seconds after zero throttle. That's to just prevent the shunt field from draining the batteries when, say, stopped in traffic or something such as that. And I've also installed a dedicated 50 amp feed for the power steering pump there, because I had upgraded it to a standard 40 amp blade fuse, but unfortunately it blew that as well. So I've now gone up to the bigger size of blade fuse there, and that's on a dedicated circuit now that runs straight from the battery positive terminal there with very thick cable. And so far that it hasn't blown that fuse, so I think that's hopefully the power steering fuse issue solved. And as I say, we have the shunt field control issue solved at this stage, but I still have to have some kind of a system for controlling the shunt field current, which I haven't quite settled on a fix for that. So I'm just powering it straight from the main traction pack at this stage, which is currently still at 48 volts. The maximum power that I can apply to the shunt field is going to be, I think it's about 72 volts. So eventually I'll have to have some kind of control system in there to handle that. So for now, a contactor there is doing the job satisfactorily. Okay, so I've got the car on charge now at the minute. You can probably see got the charger cable in there, and unfortunately I've only got a crappy 13 amp supply, so I have the charger current turned back down, and at the minute now it's in absorption charge, and as you can see there now, it's charging just under 10 amps average. We can see the voltage is quite all of the voltage and current readings are quite steady there. And I'm not sure if you can hear the sound coming from the inductor here. It's the ticking sound. That's from the pulse charging, and to say that has completely solved the noise issue that I had here, and the batteries seem very happy as well with that. And you can see here, this is our Victron 12 volt 15 amp charger here. That's just for charging the 12 volt auxiliary battery. It's got a little LED on it there that is blinking fast at the minute, and that tells us that it's in bulk charge. So it's still effectively bringing the battery up to absorption voltage at this stage. So as you can see, the charger seems to be operating very well now. I seem to have gotten the problems out of it. So that's it for that. Okay, so just in the back the back battery area now, and I don't know if you can see it from that bulb, but you can see the bulb is pulsing there. It's because the charger is taking 10 amp pulses from the mains at this stage, so that's causing the power to kind of blip a small bit here. So as you can see, we've currently got our 4 Odyssey batteries now installed on the battery tray. I'll try and get a bit of better height on the subject there. As you can see, the trays are just built from some 40 by 40 by 3 angle section, and I've made up two supports here that basically go along the car's chassis rails and are bolted through them for security, and the heads of the bolts are sunk down into the box section here, and that permits the batteries to take up the full space available here. As you can probably see as well, I've got a kind of a lining done on the angle section here. That's just pieces of ordinary scrap inner tube that's been cut into strips and secured onto the steel with this urethane sealant. It's extremely tough stuff, this, and only thing is, whatever happens, don't get it on your hands. Very hard to get off the hands, that stuff is. But it does a great job of bonding things, and the purpose of this is just to take out the kind of pressure between the battery cases and the steel here, because it would tend to eat its way through the plastic battery case from the vibration and bumps and that sort of thing. And so I still have to trim off this stuff here. I haven't had a chance to do that as yet, and we just got a piece of I think it's 25 by 4 angle, aluminium angle that I happen to have. That's just forming a strap to go across the top of the batteries, and that treads down into a bit of 40 by 10 flat there that's tapped M8 to take a piece of threaded bar. And so that's the main battery area there. It'll be 5 batteries there and 3 across this area here. And we have just some holes drilled here for some more 8mm threaded bar to hold everything in place. Oh, and this is our back battery fuse here. I was fortunate that I took the fuse holder apart, and I could actually get it to fit across 2 of the battery terminals here, as you can see. And that guy there basically is dual function. It's the back battery fuse, obviously, and it forms a jumper between 2 of the batteries as well. So it meant that I didn't have to, you know, kind of build up cables and bracketry for the fuse holder, and it just made the job that bit easier.